Perfect. Hey guys, thanks all for joining the session. I'm Anurag, and he's Matt. I'm the product manager leading the dev platform for Snowflake.
I'm a software engineer from Voltron Data, and also on the Apache Arrow PMC.
Yeah, and we'll talk a little bit about what we have been doing in our dev platform, what's all the new things we're building for developers, and then we'll talk about some of the enhancements to our drivers. And then Matt here will talk the partnership we are doing with Voltron Data, building more Apache integrations into our drivers. Perfect. So let's get started. So quickly wanted to talk about why we have been investing on the dev side. So as you see, like right now, our focus has been app development, and Snowflake has been kind of building this new feature set like Snowpark, native apps, and this is kind of bringing a new set of personas, kind of moving away from data engineers and bringing more app developers who want to have more richer integrations with Snowflake. And that's where kind of we have been kind of focusing on our developer platform strategy. And yeah, so we have been kind of working a lot, and you had seen some good announcement in the keynote today. We are kind of building from scratch our core REST APIs, which we are going to kind of do a private preview in the coming months. We are investing on our Python APIs, so you will be able to use Python APIs across Snowflake without having to call any SQL interface. We are investing, we actually announced a PR for Snowflake CLI, which allows you to have command line interfaces to run apps like Streamlets and Snowpark containers. And then we are doing a lot of work on the DevOps tooling, like CI/CD and Git integration with that. So let's just talk about what's all coming right now, which you guys can start using. So like I said, we have introduced the new Snowflake CLI. This is an open source command line interface designed for Snowflake. This allows you to create, manage apps like Streamlets, native apps, and also Snowpark containers. And I'll show you a quick demo about that in the coming slides. We also have Git integration. We just announced a PR for that. And this allows you to run, edit, and collaborate with Snowflake experience with assets that exist in the Git repo. And this will make it so easy for you guys to run CI/CDs and be able to kind of have your unified versions of your artifacts in the GitHub repo itself. The next thing which we are announcing, and you guys will be able to use in the coming weeks, will be our Python APIs. So this is a kind of a full holistic approach to having Python as a first-class interface for Snowflake, allowing you guys to able to access any objects in Snowflake with Python. We are introducing tasks and DAGs, and also Snowpark containers. And I'll show you a quick demo quickly on that. But then in the coming months, we are going to iterate and build more access to objects so that you have one unified library which you can go and install, like pip install Snowflake, and able to get access to all these objects in a pure first-class Python object API. The next one which we have already out there is our SQL REST APIs. This is something which our developers already love. And we have seen a lot of interesting use case where you can use the SQL REST API, and you can build custom REST applications. You can use it in places where you're not able to use our drivers, obviously because you want to use something with a little bit more lightweight. And then we are kind of investing more on this. So the REST APIs which you show, it's kind of an extension of the SQL API, and we are going to build an holistic REST APIs, meaning you will have an open API access to all these APIs in the coming months, along with the SQL REST API, which is already there. We also have something called API Playground. And this is, I'm not sure whether everybody knows about it, but if you go to developer.snowflake.com, you can actually play live with our SQL APIs with Postman collections. So you can go today and use the Postman collection and quickly be able to run SQL REST APIs and able to use it for testing without having to do any coding or any kind of sign up for clients for it. Then the last but not the least, I want to talk about the drivers. So this is a pretty critical part of our business. Almost every customers and partners use our drivers. We provide drivers in over 7 languages. Most of them are open source except ODBC. So you can go to GitHub, you can collaborate and open issues, and we actually work very closely with open source developers to able to have them provide pull requests. And we're actually investing a lot into our Node.js and .NET and Go drivers in the coming months, meaning that we are kind of making them at par with our Python and JDBC and ODBC, meaning developers who want to build applications with Node.js, with .NET will have the same set of capabilities as you may have in the Python connector today. And like I said, like we have a huge team which supports this. This actually brings in almost like millions of dollars of money for us. And we do like releases every month. So in the last 1 year, you can see like really big improvements which we have done in Python, .NET. And in the coming next few quarters, we're going to invest very heavily on the ORMs. So you'll see support for Entity Framework. You'll see support for Hibernate. And we are doing a lot of work to make Apache Arrow as a first-class interface. And that's something which Matt will talk in his demo. But this will make sure that you are getting the best performance and the best language to use to talk with Snowflake. Perfect. And you can go to developer.snowflake.com, and all of these clients are available. There's no charge to use the client, so you can use it. Feel free to open GitHub issues. We do have a dedicated team which comes and reviews all the triages, all the issues. So that would be an awesome place for you guys if you have anything which you want to provide us as features or inputs for these clients. Perfect. So I'll quickly jump into 2 quick demos which I want to show. Both of them are related to what we have announced today. So the first demo which I will show is about Snowpark containers and how you can quickly use Snowpark containers with our Python API. So this is a brand new Python API which we have built. And in less than 5 steps, you will have a proper container running in Snowflake without having to know anything much how the containers are working or what you have to do inside of containers. I have already ran the notebook just because of short of time, but you can see that it's pretty easy to go and declare a compute pool. In the compute pool, you can actually choose an instance family, meaning you can have different GPUs here. You can declare your min and max nodes. And then once you create your compute pool, you can then fetch your image registry. The image registry is the one where your containers, you're adding your container image. And here we have a container image of a web server which is running. And then from there, you can quickly create a service on top of it, quickly with the one step here. And then you can use that service to either suspend the service, resume the service, or even have the service running for a long time. And once you have the service running, you can quickly go to this endpoint. And this endpoint is the one where you can now see the actual web service running. So this is all something which you can do within one notebook, within that 4 or 5 steps which we have, all in Python. There is no SQL interface which you have to learn and understand here. And in matter of 5 minutes, you will have a running web server running all within Snowflake. The next demo is about Task and DAG. So I know a lot of developers use Task and DAG to create their data pipelines for creating their ML pipelines. And till now, the only way you can create is using our SQL interface. With this new Task and DAG APIs, you can quickly now declare your tasks in a programmatic Python API, first-class API. So here you can see we have created 2 tasks. And we have kind of added the task in the task definition to call a stored proc every day. And then these 2 tasks, once you create them, you can resume them, you can list in. And then you can actually create a DAG using those tasks. So DAGs is a higher level API which we have also introduced, which allows you to do a better orchestration of the tasks. And here for the demo, what we are showing is we have 2 tasks which we are adding in the DAG. And these 2 tasks are then kind of integrated, meaning that one task will trigger the other task. And then when I run the DAG, it actually runs both of these tasks together. So now if I go back to Snowsite, you can see the tasks, the DAGs are already created here. And if I go to the graph, you will see that these tasks are now linked in the fashion which we wanted for the DAG. And then, yeah, you can see the run history, everything from here. But that's quickly about the task APIs, which you can now use. the last but not the least, I want to show a quick demo about the CLI, which we also have released. You can go today and you can access it at Snowflake Lab. So it's available now in the PRPR. And what it includes support for Streamlit, Snowpark containers, and Snowpark. And the demo, which I will show quickly, is a quick example of how you can now use Snow CLI to create a stored proc, use the init to create the stored proc, and then quickly able to run the stored proc. OK, I'll take a pause here and hand over to Matt. Yeah.
Thank you. Thanks. So if we can just get the presentation back. OK, so NanoArrows, Snowflake, and the drivers that we were all talking about, and making everything easier to use, more performant. So if you're not familiar with it, very, very quick primer, Apache Arrow. We got an in-memory, column-oriented data format. Representation is the same on the wire as it is in memory, so you don't have to pay serialization, deserialization costs as you go from one system to another or one runtime to another. There's implementations for it in almost any language you can think of. There's an implementation for Arrow, the idea being that they can really easily communicate with one another back and forth. So Snowflake utilizes Arrow internally for a lot of its communication and for high performance there. In fact, the Snowflake Python connector uses PyArrow under the hood. And that's how it gets the access and the compatibility with pandas. Now, there is a drawback to it. PyArrow is very big. It's very large because it contains not just all the Arrow functionality, but also a bunch of utilities for compute, for data set in multi-file data set APIs, and other high performance compute and manipulations of data and data sets, files, Parquet, whole file system setup, and so on. Now, the Snowflake Python connector doesn't take advantage of that. So it doesn't need those extra functionality, and it doesn't need to be really big. So that's where NanoArrow comes in. NanoArrow is a small, self-contained C library that implements Arrow, and just does that. It implements the format and the IPC, interprocess communication format, and that's it. It's intended to be vendored and tiny. In fact, when it's compiled, it's less than 350 kilobytes. So the Snowflake Python connector, using NanoArrow, becomes really small. Instead of the current case where the wheel is 15 meg and the actual installed size is 53 meg, it goes down to 5 megabytes for the installed package. The other benefit is that right now the Snowflake Python connector has to pin the PyArrow version, which means that whenever there's an upgrade to the PyArrow version, they have to do maintenance to update the Snowflake Python connector to use the new version. But by using NanoArrow, they don't have to deal with that maintenance anymore. It's just, they get only what they need and just that. And so the Python connector using NanoArrow is going to be in preview in July, and then released shortly after that. And let's see why does this matter? Why you care? Well, one big desire of Snowflake customers is getting AWS Lambda functions. Now, right now, if you want to make an AWS Lambda function using Snowflake, you have to use the REST APIs or other interesting workarounds because you can't actually use the Snowflake Python connector because it's too big. So here's our little demo infrastructure. We have our custom API, we have the Arrow Snowflake data converters, and then there's the NanoArrow library under the hood. Now, if you try to use that and deploy it to AWS, you get this message you see here, that it's too big. The unzip size must be smaller than a certain size for you to actually deploy it on AWS Lambda. But if we build a version of a Snowflake Python connector using NanoArrow, you see it successfully deploys. Because now it's small enough, it succeeds, and you can actually use the Snowflake Python connector with NanoArrow successfully to deploy an AWS Lambda function. And here is actually hitting that URI to show you that I'm not joking, I'm not making it up. Here we actually hit it. So the next thing I want to talk to you about is ADBC, Arrow Database Connectivity. Many of you may be familiar with ODBC or JDBC. Same concept, only instead of a row-oriented interface, it's a column-oriented interface that produces Apache Arrow data natively. We have bindings in all the languages you see here for ADBC, Ruby, R, Python, Go, C++, Java. And the idea there is now we are releasing a driver for Snowflake for ADBC. Now, to kind of emphasize the whole why not ODBC, JDBC, let's go through like the basic workflow. How does an app actually use ODBC or JDBC? Well, you have your SQL query. You send it to the ODBC or JDBC API. That's going to use one of the drivers you have, like the Snowflake driver, for example, which is going to use some database-specific network protocol to talk to the database. It's going to make your query, it's going to evaluate, it's going to return the data in some database-specific format. And then, if that database is column-oriented, like Snowflake is, now you're going to pay a cost, because you have to transpose those columns to rows, because ODBC and JDBC are row-based. And then if you want to actually do analytical computations on them, you're probably going to convert it back into columns anyways. So with ADBC, you avoid those transpositions. You don't have to do those conversions. So we have this one library that exposes a C interface. So anything that can call a C function can call the driver and interact with ADBC. So even if you're not one of those languages that we have those bindings for already, it means that we have a path to add drivers for new environments and languages. And to kind of exemplify that, let's show building an app using Shiny in R that calls Snowflake directly using that ADBC driver. And this is a highly requested feature. So you can see here the kind of the architecture here. We've got our application. It's going to use the ADBC interface of the bindings, and it's going to call the Snowflake ADBC driver, which is then going to interact with Snowflake internally as a library that we distributed. Over here, you can see highlighted all the code that we needed to add to the R to actually call ADBC. We initiate the connection, and then we just call read ADBC and give it a query, changed it, set it up, and then this little demonstration here shows that we're not making it up again. You can see that someone's in RStudio right here with all the code I just showed you, and then we're going to click Run App, and boom, there you go, running right inside Shiny, right inside RStudio, running an application that's querying Snowflake using R. And that was enabled in the span of a day or so because we already had the ADBC driver. Because once you have the ADBC driver, you can enable other environments and languages as long as they can just call the C interface. So for example, in addition to there was no official Snowflake driver for C++. Well, now if you're using C++ and you want to call Snowflake, you can call the ADBC driver. Simple as that. The R ADBC driver is deployed. You can install it easily. If you're using Go or Python, any of those, if you want to be able to easily leverage Snowflake in new and exciting environments that don't already have existing drivers, you can just use ADBC. We also made a Medium blog post about it. Check it out. Just do a quick Google search, Snowflake ADBC, you'll find it. And check it out. Please try it. Try it out. Tell us what you think. Hopefully everybody enjoys it and enjoys the benefits, the performance, the usage. Yeah. And so that's it. Thanks.
Perfect. Thanks all. Thanks, Matt.